All right, Unit 9, Chemical Reactions, Day 4. Now we're going to talk about types of chemical reactions. Specifically, today we're going to talk about a synthesis and a decomposition chemical reaction. Okay, so there are a bunch of types of chemical reactions that we are going to learn. We have synthesis, we have decomposition, we have single replacement, double replacement, and then combustion. So let's get into it. Predicting the products. So, what is a synthesis reaction? Two elements combine to form a compound. Synthesis, guys, is just a fancy word that means making. You're making something. You're making a compound from simpler materials. So just think making. Synthesizing, making. Synthesis is you're making a compound from simpler or smaller materials. So the very common form for synthesis is an element plus an element yields a compound. So A plus B yields AB, because A and B will react to give you a compound with A and B in it. Because remember, you can't have to have the same amount of atoms on the reactant side as you do on the product. So let's look at some examples. We have sodium and we have chlorine. Sodium is a metal, chlorine is a nonmetal. So if you remember your naming rules, you're going to get sodium chloride. So you keep the same name as the metal, and your nonmetal, you drop the ending and you add "ide." So it's going to be sodium chloride because it's a metal and a nonmetal. Now let's look at the next one. We have magnesium phosphorus. That is a metal, and phosphorus is a nonmetal. So we're going to get magnesium phosphide. Remember, drop phosphorus, the us part, and add "ide." Now we have sulfur and aluminum. Remember, the metal always comes first, so we're going to have aluminum sulfide. Now let's talk about the next chemical equation or type of chemical equations. A decomposition. A decomposition is a compound breaks down into elements and or smaller compounds. So think of this as opposite of a synthesis reaction. A compound is broken down into simpler compounds or elements. So you're going to take something big and break it down to small. Synthesis took something small and made something bigger. You synthesized, you made something. Decomposition is taking that compound and breaking it down into simpler parts. All right, so what's a common form of that? It's just the opposite of the synthesis. So you have a compound yields an element plus an element. We call that, or we represent that with AB yields A plus B. So let's go through some examples of decomposition. So we start with potassium nitride. That's definitely a compound. Since it was decomposed, it went through a decomposition reaction, you just need to go back to the nonmetal's original ending. So you have potassium, because potassium stayed the same even when we were synthesizing them. The metal stayed the same. Then you have nitride, but in this case, nitride is no longer in a bond. It's by itself. And when nitrogen is by itself, we just call it nitrogen. It's that simple. So basically what I'm saying here is you go back to the nonmetal's original ending. Okay, let's talk about some spatial decompositions, all right? The first one's going to be chlorate, a metal chlorate. So an example of a metal chlorate in decomposition would be barium chlorate. Chlorate looks like this. You use your polyatomic ion sheet. It is ClO3 with a -1 charge. So you have a metal chlorate, and that metal could be any metal that it's with, will yield a metal chloride plus oxygen. And here's the why it's special. Whenever a chlorate is going to decompose with a metal, you always are going to get chloride and oxygen. Whatever metal you had is going to be with chlorine. So it's going to be, in this case, barium chloride plus oxygen. So let me say this again. When chlorate decomposes, a metal chloride, here's your metal, here's chloride, and oxygen gas are produced. Chlorates are often referred to as oxidizers because they produce their own oxygen gas when they react. So that's a fun fact. And we'll talk about oxidizers at another time. So what's next here? We have another example of special decompositions. And now we're going to talk about carbonate. So an example of a metal carbonate decomposition would be potassium carbonate. So it's going to be a metal with carbonate, in this case, yields metal oxide plus carbon dioxide, okay? So there's carbonate, CO3, 2 minus. You found that on your polyatomic ion sheet. Now, whenever carbonate decomposes with the metal, you're going to get that metal oxide plus carbon dioxide. So you have potassium carbonate yields, decomposes, goes through a decomposition reaction. It will yield potassium oxide plus carbon dioxide. So how can you remember this? Well, if you see carbonate and it's in a bond with a metal, it's going to produce whatever metal, oxide plus carbon dioxide. And I like to remember this with carbonate. Carbonate will make carbon dioxide. So you literally have carbon in the name. If I know what makes carbon dioxide, I also know that it will have an oxide attached to the metal. In this case, it's potassium. So let's look at our next special decomposition. And that's going to be a metal hydroxide. And here's our example. We have 10,4 hydroxide. So whenever you see a metal hydroxide go through a decomposition, it's going to yield that metal that it's with. Ooh, what are you doing? Go back. Thank you. That metal that it's with, oxide plus water. So here's hydroxide. It's OH minus 1. 10,4 hydroxide decomposed to 10,4 oxide plus water. So whenever a metal and a hydroxide decomposes, you're going to be left with oxide and water. And a way I like to remember that is hydro, means water. So you have a hydroxide, hydroxide, reacts with a metal, decomposes down into smaller components, and you're going to get that metal oxide plus water. So let's review them real fast. We had to begin with chlorate. Chlorate has chlorine in it. So if a metal chlorate decomposes, you are going to get that metal chloride plus oxygen. So you have chlorine and oxygen, okay? The next one was carbonate. So it had carbon in it. So whenever a metal carbonate decomposes, you're going to be left with that metal oxide plus carbon dioxide, carbonate, carbon dioxide. And our last special case was hydroxide, hydro, water. So whenever a metal and hydroxide react, whenever metal and hydroxide decomposes, you're going to be left with you're going to be left with the metal. In this case, it was 10. Sorry for reading 10. You'll be left with whatever metal, oxide, plus water, hydro, water. That's it for the notes today.